Welcome back to another HamsterChefs devlog. In this devlog, I dove deep into building an interaction prompt system, the kind of UI that tells you to press F to grab or press B to pick up when you're near an object. It might look simple, but the small piece of UX is one of those deceptively complex systems that makes gameplay smooth and intuitive, or not at all. At first, I wanted the game to automatically switch between prompts depending on whether I'm using a keyboard or a controller. So if I'm on PC, it should show press F, but if I'm on PS5 or Xbox, it should switch to press square or press B. I found that the Unreal built-in common UI plugin or just the enhanced input system wasn't flexible enough. It would have meant rebuilding everything manually. I tried to search for tutorials, and it's always involving me building a whole table for keys, meaning for what keys on each platform. So it detects and switches icons from that table. I mean, shouldn't enhanced input action already take care of that? But turns out switching input UI icon is still parts of our homework. Correct me if I'm wrong. But yeah, instead I decided to use an external system called Easy Input Prompts by Nervy. It includes full button icon sets for PlayStation, Xbox, Switch, and PC with dynamic switching. Give it a visit on their Fab page and I recommend it very much. It's a neat and affordable tool that saves a ton of time. With that installed, I created a 3D widget inside the character blueprint called Prompt Widget, which would serve as the base UI for interaction prompts. Inside that widget, I built a simple horizontal box containing two elements: the input icon, the F or control button. This any icon will change based on what current input detected, and the action text like grab pen or put plates. So this to pick up text, it will be changed on based on what's action that we are going to execute when we detect an item in front of the characters. Remember the logic behind grab and drop system, which revolves around three core variables: what we're highlighting, what we're holding, and whether there's a table in front. These determine what action is available to the players whether we press the interaction button. For example, if we're holding nothing but there's a pen in front, pressing F will grab the pen. If we're holding a me hamster and there's a table in front, pressing F will place the me hamster on the table. If we're holding a plate and facing another plate that has food, we can scoop or pour between them, depending on the state. All of this logic ran after pressing F, square button, or an A button on Xbox, meaning the player never saw what action they could perform until they pressed the button. That made interaction feel clunky and unresponsive. I also have a problem in the past where I expect the F button should do a thing, but instead it's something else. For example, here I expect we should be scooping the me hamster from plate to our plate, but since the calculation happens after we press F, we never actually know what will happen. I actually came across this idea because I watched Blargis video about making game mechanics that don't suck. He explained very well why his air dash mechanic on his Blood Thief game, the problem was very similar. His highlighting, which should be where the char would dash attack, is bad because bad feedback and doesn't tell correctly what will happen, so predictable result is a must. So I refactored the highlight system entirely. Now the highlight and prompt logic run constantly through a filter tick event about 15 times per second. How I do that is basically just using a branch about 2 times, so it's halving from 16 times per second because tick was running every frame, so 60 fps 60 times per second. Then it's halved to 30 times per second, and then it halves again into 15 times per second. Then from that 15 tick, we start a capsule trace to detect the interactable objects in front of the player. Instead of relying on the character's collision, the capsule trace gives us much more reliable detection. It finds what under the player's focus, check whether it's a valid interactables, and update the highlight and prompt accordingly. If the highlighted object change, the system continues to the updates. If there's no valid hit, it clears the highlight and hides the prompt. These 15 tick refresh checks felt more responsive than relying on the item entering or exiting the collision just like before. This will be a huge improvement in terms of feedback and clarity. That's only the detection parts that fixes instability and unresponsiveness. Next is to actually run the state calculation from it. And from it, we will know what will happen before we press that interaction button. To prevent miscommunication between what's shown and what actually happens, I introduce a new integer variable called GrabDropPromptMode. Each possible state like grab, drop, scoop, pour, and more just get assigned an integer value. So we don't execute the action, but we only store this value that is determined during highlight detection and store it until the player presses F. That way, we know exactly what is going to happen before the button is pressed. When the button is finally pressed, it's just execute the stored action. After setting up the logic side, let's move on to displaying the actual UI prompt. I created an event called showPromptUI, which spawns the prompt widget and attach it to the player's 3D widget component. The widget's visibility toggles on and off depending on what's detected in front of the player. For instance, press F to grab pen, press F to put hamster me on table, or press F to scoop from the plate. When nothing's in front, the widget hides itself. To make sure it doesn't flicker or shake, I compare the new prompt with the previous one and only updating it when the action is actually changed. This small optimization removes visual jitter completely. I wanted the interaction prompt to hover directly over the highlighted object. I created a custom event again called movePromptUI. We retrieved that highlighted actor's world transform and the actor's bounce. And because we are spawning that widget from the character, we need relative location from the characters to the highlighted object. And for the widget to not be in the center location of the highlighted object, we just add the bounce so it will get further a little bit. With that, we use moveComponent2 node. This node is magical, it's animated, and the motion is interpolated over time instead of snapping instantly. And with this, the prompt system complete. It not only detects and displays actions beforehand, it now also floats precisely where your attention is, right above the object, because I ended up using only the Z-axis from the bounce, so it's adding up from the center of the highlighted object, and actually slightly offset to the right because I offset it on X-axis slightly in the screen space when we draw the widget. And that wrapped up the devlog. By the end, the input prompt system was fully working, dynamic, smooth, and platform aware, and the highlight detection was now smart enough to update even before pressing any button. It might look like a small detail, but it makes a massive difference in feel, interaction, and it now communicates clearly what the hamster will do, so no more "wait, why did I drop that?" moments. Thank you for watching, like the video, subscribe, follow our social media, see you next video, see you next content, thanks for tuning in, and see you in the next HamsterChefs devlog.